This is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Don Felker.
And I'm Kaushik Gopal. Before we kick things off today, I want to take a moment and thank our sponsor for this episode, Rollbar. But I'm going to do it in a different way today. Here's the thing, Don and I have told you how amazing Rollbar is in a bunch of episodes now, and we're really lucky to have them again as our sponsors. They're this fantastic service that provides real-time error tracking for us developers on the web, mobile, they're everywhere, and a whole bunch of really big companies use them. But I'd like to start pointing you folks to specific tips or ways of using Rollbar where you'd really start to appreciate the service. So recently I noticed we were getting an error from our backend endpoints. So I pulled up the dashboard for Rollbar and sure enough, I could see the error there. I clicked the link and dove down to the details. And Rollbar tells you when the error was first seen, when it was last seen. They give you a whole bunch of really intuitive details that are useful to quickly understanding the issue. But sometimes as developers, all you really care about is just quickly reproducing the error because you want to understand how this thing happens, right? So right there in the occurrence page, they give you this feature called replay curl command. And this is crazy useful. Usually I simply just copy paste that command onto my terminal and I just start using that to reproduce the error. They take care of supplying the right headers, the right parameters. It's as though your app actually sent the request. I love using this feature. It's small and nifty ways like this that Rollbar makes it super easy to quickly detect, diagnose, and eventually just nuke those pesky errors. If you're curious and you want to try this replay curl command feature out, then we got a special link for you, and it's pretty simple. rollbar.com/fragmented. As part of a special offer for our listeners, they're giving their Bootstrap plan free for 90 days. That's 300,000 errors tracked for free. So you can definitely try this replay curl command feature that I mentioned and see how useful it can be for you. So use our special link, then you're happy because your application has less errors, which means we're happy, and then eventually Rollbar is happy. Everyone's happy in the story. Anyway, thanks again to Rollbar for sponsoring this show. We love their service and we're super happy to have them as a sponsor for this show. Thanks again, Rollbar.
Welcome to this week's show. Before we get going, there is something I would like to say. I'd like to say thank you to all the listeners that are out there and who keep listening to all the various shows we have. And I'd also like to thank all the new listeners who have recently joined us. Without you folks, we wouldn't really be doing this. We do it for you guys and gals and everybody out there. So just a big thank you to all of you guys out there. You guys have been really giving us a lot of feedback on Twitter and Google Plus and in person. So thank you very much. We love all of the feedback and thank you for listening.
Absolutely, 100%. We love getting all this information. It just keeps us going and it informs us on how to move the show forward. So thanks again.
Definitely. So I'm super excited about today's talk, Kaushik. And one of the reasons is because I feel as a developer, it's important to have hobbies. For example, lately I've been getting into a lot of kind of like Internet of Things type of things. And so a lot of times our hobbies are non-work related, but at the same time, they can also cross that boundary like an Internet of Things type of programming. It's kind of work related, but not work related. So today's topic, I feel, is one of those topics where developers can use to kind of cross that boundary to start tinkering various things that they may already have. And it's with a technology that you actually probably already have in your pocket and lying around your house. So Kaushik, could you clue the listeners in on what we're going to be chatting about today?
Sure. So we've always been curious, like you said, about technology and like the software that's surrounding embedded devices or other devices that basically run sort of like low-level control program. But I'm not sure about you, Don, but like I've never had the chance to actually work in any sort of like formidable way, like at work with any of these devices. And, I thought, well, there might be quite a few others in the same boat as us. So we thought we'll take one of these technologies and start with Bluetooth and Bluetooth Low Energy and just try to get a sort of high-level picture. We actually found someone who does have experience and is really, really good at this stuff and would probably help us find our way around this. So we'd like to welcome a friend of the show, Dave Smith, also known as devunwired.
Welcome.
Hey guys, thanks for having me.
Dave, if you could do us a little favor here and tell the listeners a little bit about yourself, where you're from, kind of what you do and how long you've been doing Android and such, just so we can kind of get some background info on you?
Sure, absolutely. So I've been working with Android for, I guess, about 7 years now, since mid-2009. I'm currently working as a freelance Android consultant. And I've really worked with Android at all layers of the stack. I've done application development. I've done a little bit of work with Android in the embedded space. I've done some developer training and courseware development over the years. So I've really been all over Android those past few years. But previously, before I started working with Android, I was actually a hardware engineer. I did systems engineering for an M2M company, which M2M is essentially what we called IoT before it was cool. And I did a lot of firmware development for them, and I also designed a lot of sensor-based electronics. My background is actually in electrical engineering, not so much software. So I did a lot of work with low-level software development, and so my life prior to Android was mostly about wireless radios and low-level firmware and that sort of thing.
Wow, so you have quite the background in hardware, I would say.
Yeah, I mean, it's an interesting change going from something like that to, say, mobile software. But, when I saw mobile devices and Android and iOS and all these things start to come into the market, I looked at that and said, well, hey, that's really just an embedded system. I mean, they're designed very much like embedded systems where everything's tightly integrated, including both the hardware and the software stack. So it was sort of a natural transition, even though technically speaking, it's a little bit of a higher level of software development than I maybe had done in the past.
Right. And that makes sense. And I guess in this category, what also falls in is like Bluetooth and Bluetooth LE, I suppose, right? So before we start, we want to try to get an understanding like how this all works. So maybe we should start off with a little background on what exactly Bluetooth is. Like, what is the technology and how would someone use Bluetooth, right? So how exactly did Bluetooth start? Don, can you kick us through some of the things that you think helped bring about Bluetooth?
Yeah, definitely. So from some of the research that you and I have done, we can tell that it was invented by Ericsson. And Dave, if any of this is wrong or incorrect or it's missing some information, feel free to interject. We know it was invented by Ericsson, and basically it's used as a way to transfer data, wirelessly, no cables involved. Now, the limitation is it's used over relatively short distances. So it's not like you can, go a quarter mile down the road or even, some Wi-Fi distances. It's pretty short. There's been different versions, 2, 3. At 3, they had different, transfer speeds. And I think currently we're at version 4, which kind of brought in Bluetooth LE, and LE stands for low energy. Now, I've heard this is where Bluetooth Low Energy was introduced. I think it was actually started by Nokia at some point under a different name, started with a W. I forget what it was. Now, the cool thing that I've also heard about Bluetooth Low Energy is that these devices can run for a super long time on batteries. Dave, do you know is that true, or do you know how long these things can run on these batteries and for BLE?
Sure. Yeah. I mean, obviously the LE stands for low energy. So the idea behind the addition to the low energy portion of the Bluetooth spec, which you did say correctly, was introduced in Bluetooth 4.0 specification. The idea behind that was that you could use the basis of the same Bluetooth stack that they'd been using before, but use it in lower power use cases, or use it in devices that may have very small batteries, maybe even just a coin cell battery, and use it in an application where that could run out without having to change the battery for weeks, months, or even years. Part of what kind of went along with that is the configurability around how often data is transferred, how much data is transferred. Those sorts of things weren't necessarily as configurable in the earlier versions, which allowed you to sort of tune the system to have more control over exactly how long this device could live in the field on whatever power source you had connected to.
And with most current devices, are all of them basically now on the Bluetooth 4 spec, or is 3 also prevalent now?
Yeah, I would say from a mobile devices perspective, all common devices that you'll find in the market are definitely supporting at least Bluetooth 4.0. The latest version of the Bluetooth spec is actually 4.2, which has introduced a number of other things, not even necessarily all of them related to LE. Bluetooth LE is really just a subset of the overall Bluetooth specification. So, there are some additional things that have been added that you might find in other devices, whether those are iOS devices or other Android devices. But Bluetooth 4.0 is pretty much the base standard that you'll see technology, at least for mobile devices in the market today, yes.
So, Dave, what exactly is the charm behind Bluetooth? As in, why should I care about Bluetooth? Because, I mean, there is Wi-Fi, because as I understand from what Don was telling me, it's a mechanism of transferring data between 2 points, right? So why Bluetooth? Like, what is it about Bluetooth that makes it interesting? Why can't I just use Wi-Fi or, God forbid, infrared or something?
Well, if you can find an IRDA port on a phone, please tell me, because I'd love to buy one and keep it.
Those things are antiques, right?
Yeah, that's exactly right. No, I mean, you're right. I mean, Bluetooth and Wi-Fi in a lot of cases can solve similar problems. So to some degree, it's just yet another solution to some of those things. Bluetooth is a wireless protocol or wireless technology that allows you to communicate more often than not directly between two devices. So in sort of a peer-to-peer fashion. Wi-Fi can also do this, although it's not typically used in that fashion. So the peer-to-peer or direct support associated with Wi-Fi isn't necessarily always built into the different mobile platforms you might be working with, whereas Bluetooth is really more suited to that. Generally speaking, Bluetooth is also lower power. This is true even if you're not talking about Bluetooth LE. There's a lot in just the Bluetooth Classic specification that is also much lower power than doing similar things over Wi-Fi. Of course, that also means that, as you mentioned, the distances are often a bit shorter. But generally speaking, the use cases for wireless data transfer tend to circulate around, I'm in the same room as the thing I want to talk to, I just don't want to plug into it. And so for those ideas, Bluetooth just kind of is a natural fit. It started out as sort of a wire replacement functionality where something that you would have plugged a peripheral in to do, you could do that similar sort of functionality over a wireless mechanism, and it wasn't necessarily designed for creating small networks like Wi-Fi is, although technically speaking, that's actually supported in the Bluetooth spec as well.
Right. So I imagine when Ericsson started off, they thought what was the name of that cartoon on Cartoon Network I used to watch? The Jetsons? I think it was the Jetsons, right? So that was I think Ericsson's way of we don't need wires in this world anymore. So let's just try to do it through air. And I guess Bluetooth was the sort of impetus for that solution, right?
Yeah, well, and you can see that in the prevalence of things that are Bluetooth connected now. I mean, Bluetooth is a ubiquitous thing. Almost everything has Bluetooth in it, whether it's the thing in your phone or all these different peripherals and accessories you can buy at the electronics store. Bluetooth is used to connect common computer accessories like keyboards, mice, and joysticks. Bluetooth is in your car. You can buy a headset. And now we're seeing Bluetooth more in home devices coming along with the IoT functionality. People are talking a lot about beacons. I mean, all this stuff and it all uses the same core technology under the hood, which is Bluetooth.
And I think that's the best point, because almost invariably any commercial device or anything that you purchase today in the market almost always supports Bluetooth. And I think therein lies the huge advantage, right?
Yeah, exactly. Especially with, like I said, with all the IoT and some of the wearable stuff that's getting really interesting as well. All of these things, because they're sort of remote devices or they're often very small devices, the power supply capability of these things is very limited. And so Bluetooth, and more recently at least Bluetooth LE, just becomes sort of the natural choice of what you would use to connect that to, what everybody has in their pocket, which is their smartphone.
Okay. And a couple of quick dumb questions. With some of these use cases that you actually mentioned, just so our listeners can get a clear understanding of the differentiation between what exactly Bluetooth Classic is and what Bluetooth LE or low energy is. I use a wireless keyboard here, from Apple, and this is a Bluetooth keyboard. So this would obviously, I guess, be Classic?
Yeah, I mean, at a high level, the differentiation between Classic and LE has a lot to do with data rate. So things where you might have to transfer large amounts of data or do that in a very rapid succession, those are typically Bluetooth Classic type functionality. So you mentioned the keyboard and mouse. Those are generally large streams of events that are coming across the wire to the other device. And so those HID or human interface device type things, those are typically always going to be done over Bluetooth Classic. We're starting to see HID devices work over LE. There is a special profile for doing HID on Bluetooth LE because in some cases, like a keyboard, those events aren't necessarily very high rate, although in something like a mouse or a joystick, they would be. Or like, for instance, the audio cases, like you probably have Bluetooth in your car and you can connect your phone to it so that you can do hands-free calling while you drive, right? That's a streaming audio connection. So that's a lot of data. Yeah, those types of things are going to be classic functionality. Whereas some of the other pieces we mentioned, like the wearables and stuff like that, those are very low data rate in, reading sensor data and transferring it once every few seconds or something like that. Those types of things can typically be implemented over Bluetooth LE.
And I've seen a lot of different industries moving towards LE from what it seems like, especially interesting ones are the ones that are in healthcare. I've seen like things like blood pressure profiles and glucose monitors and stuff like that. So those are all very valid use cases for LE from what I can tell. And like you said, the wearables, there's ones even out for, bicycles that can help track, cycling speed that just read that sensor data every once in a while and it's not so much high output. So it's cool.
The coolest use cases I've seen is like if you have your kid or actually I shouldn't club these two to get together, or if you have like pets and what you can do is you can like add like a small Bluetooth sort of device on them. And anytime they move away from you, if you want to be alerted in some fashion, then like it sort of like pings you on your device or it tells you, because obviously you'd be watching your device more closely than your children or your pets, right? So that is an extremely important use case. So one thing you did offhand mention about like battery performance and stuff, right? So how efficient is Bluetooth in terms of like battery performance? Is it something that I have to be very worried about? Because I remember in the early days of my mobile usage, I always used to keep like tapping that Bluetooth icon, that toggle off, just because I was like, oh my God, it's going to drain my battery, right? Is this like a valid concern?
Sure. I mean, it's, obviously any radio on in your device affects power. And I wouldn't even necessarily say that this was a problem for Bluetooth in the early days and not anymore. But I think the idea there is that Bluetooth Classic functionality was really designed for, constant connections, streaming data, and those types of things tended to have a higher battery consumption than you might necessarily like to have on your device, to have that turned on all the time. It was such where you couldn't actually really enable use cases where two devices could communicate with each other over an extended period of time, right? The audio you're streaming or the phone call you're on, that was really the duration of that connection, just because it was low power in terms of wireless, but it was still a relatively high drain on the battery in something like a mobile device, right? So, I mean, obviously that's a known issue. That's one of the reasons that Bluetooth LE even exists. The idea being that we can reduce the power consumption to help enable some of these use cases where we just leave not necessarily the Bluetooth radio, but just we leave the Bluetooth functionality enabled all the time, right? Meaning that we're constantly looking for devices out in the wild or listening for incoming data. We can do that in the background over extended periods, days or months, without significantly affecting the battery in, a device like a mobile phone, where there's no way we could have done that with Classic. It's actually kind of interesting. One of the primary technical reasons for this is that the way that devices discover each other is completely different between the two. Inside of a traditional Bluetooth, like Bluetooth Classic, the mobile device that you have in your pocket is typically the device that's responsible for scanning the world around it to look for devices to connect to. And in Bluetooth Classic, that process was done by the mobile phone transmitting packets out into the world. So it was actually hunting for devices by broadcasting information every so often to see if it got a response from anything. And just generally speaking, with any wireless radio, transmitting is infinitely more expensive on power than receive. So if your device is talking a lot, and are doing a lot more talking than it is listening, then generally speaking, that's significantly impacts the battery more. They flipped that around in Bluetooth LE. So with low energy Bluetooth, now the scanning device is actually the listening device, and the other devices are advertising their presence if they want to be discoverable. And that reduces the power necessary to scan. So your mobile phone could be scanning, technically speaking, all the time, and it wouldn't impact the battery near as much as it would have with traditional Bluetooth.
Interesting. I guess the analogy is like the whole polling mechanism versus like maybe having like a socket or something, or having the server push the data down to the device, right? In some ways.
Yeah, I mean, if you think of it in a mobile-centric view, that's essentially what's happening, is we went from pull to push.
That makes sense. So we talked about some of the advantages, right? So what are some of the disadvantages, I suppose?
Probably the biggest disadvantage is that there's a lot to wrap your head around. I think that the mobile platforms have really helped a lot with this, although to some degree, I think it may be a bit of a double-edged sword, because frameworks like iOS and Android have done a really good job of simplifying what a developer would need to do in order to interact with these technologies. I mean, if you look at the specifications for these things, they're hundreds of pages long, and trying to keep an idea of, how do I understand these different intervals and how things connect and stuff like that? That's a lot to go through. And I think that the mobile platforms have really done a good job of simplifying. Here's 3 or 4 APIs you can use that will allow you to connect to another device and stream that data. Unfortunately, that also means that the platform makers are making a lot of decision on your behalf. And sometimes they make decisions that are incompatible with each other. So you've got some issues associated with that, where iOS devices and Android devices, for example, can't always talk to each other using what should otherwise be a standard profile, because they've chosen to make different decisions and they don't allow the application developer to configure some of those things. So some of that can be a little bit more headache than it's worth, and hopefully over time, at least on the mobile side, the platform makers will start better harmonizing with the spec.
Dave, if I'm a developer and I'm going to be writing some applications, or I want to write an application that uses Bluetooth, and I have some devices or peripherals that I can use to interact with inside of Android, what are some of the classes that I'm probably going to need to use, or what would be the best place to start looking at developing Bluetooth applications with Android?
Sure. So there's, as we've been talking about a little bit, there's 2 primary buckets here. There's the Bluetooth Classic APIs, and then there's a functionality associated with Bluetooth LE. From a Bluetooth Classic perspective, that's really been around in Android since a.k.a. Was when they first introduced those APIs. And they introduced APIs to work with a single Bluetooth profile called the RFCOMM profile, which is really just think of it as a wireless serial port. So it was a simple way to create a low-level socket connection between 2 devices that would allow you to stream whatever you want in both directions. They actually have a sample called the Bluetooth chat sample that does exactly that, right? It basically allows you to do wireless chat between 2 devices, streaming all that data back and forth over Bluetooth. So in the instance of using those APIs, the Android API structure has a class called Bluetooth Socket that is essentially the interface for doing this. There's some higher level APIs around discovering devices and connecting to devices. All of those things hang off of the Bluetooth system services. So the Bluetooth manager, the Bluetooth adapter, those types of things. Those allow you to discover devices around you, get an instance of a device and attempt to connect to it. But the real meat of things happens inside of the Bluetooth socket functionality. And that's where you can basically advertise that a device is able to receive that connection, and then make that connection from the other side and transfer data back and forth. Really, again, you just basically have an input stream and an output stream, and you can read and write raw data back and forth. In terms of APIs, that's really all we have in Android for Bluetooth Classic. There's tons of other profiles there, but Android doesn't really expose those to applications. Android supports you connecting keyboards and headsets and all this stuff, but they don't really bubble that up to the application layer. They allow you to detect that those things are there. So you could ask the APIs, do I have any headsets connected and what are they? But there's not a whole lot of additional functionality on really working with them directly. Those are really more baked into the platforms as this is an audio device or this is an input device. And they don't have, specific APIs. When you connect a Bluetooth keyboard, it just acts as a keyboard. There's no specific Bluetooth API you have to work with to do that. All that work is really on the device manufacturer side on making sure they implemented the appropriate profile so that Android recognizes it as a keyboard or as a headset, something like that.
Oh, wow. Yeah, that's super interesting. I never knew that. So does that mean if there's like some new kind of technology or there's like if Bluetooth is being used for some new kind of use case, that basically means the manufacturer has to come up with this profile that would work and then we would subscribe to those profiles in order to make use of it?
Yeah, to some degree that's true, right? So a profile in Bluetooth terms is really just think of it as a contract, right? It's a definition of a set of services that a device has to expose for interoperability purposes. So there, we've mentioned some of these profiles already, things like HID, headset, Bluetooth speaker, which is called A2DP. Each of these are just predefined set of APIs that the Bluetooth SIG, which is the group responsible for all of these things, defines ahead of time and says, if you want to make a speaker, it conforms to this profile. And then a device like an Android device just says we support the A2DP profile. And any device that we find out in the world that claims to adhere to that profile, we can communicate with it. So it's all about interoperability. And so when you see in the next version of Android, they claim that they support 3 new Bluetooth profiles. That doesn't necessarily mean that they added more APIs. It just means that at the system level, those devices can be detected and they can interact with them inside of the Android OS. And that may or may not translate to something that you can do with it directly as an application developer.
Oh, so in some ways we are again limited by what the APIs support. So that's kind of something that isn't necessary. It isn't like support library land or something, right? Like that's something that's baked into the OS. So we would need to wait for the OS in order to sort of use some of these profiles.
That's correct. Yeah, that's not really a sort of thing that they can backport because, again, as I said, there aren't even necessarily APIs associated with those things.
Right. That makes sense. I guess that makes sense.
Let's say there was some Bluetooth device that I had that allowed me to collect sensor data for whatever reason. Could I interact with that device using the Bluetooth socket and talk to it or no?
Absolutely. Well, let me qualify that by saying if you control that device, meaning you're responsible for the software that's on that device, you can ensure that it implements that one particular profile, which is the RF COM, or it's also sometimes referred to as the serial port profile. If you ensure that device exposes that service, which is really all it boils down to, Bluetooth devices are just a collection of predefined services that get wrapped up into these profiles. But if it exposes that service, then from your Android device, you can discover that service, connect to it, and stream data back and forth. So it really just hinges on whether or not that remote device, whether it happens to be another phone like another Android device or some embedded device, as long as it exposes that service and claims to support it, then you can do that even to an embedded or a wearable system.
Okay, that makes sense. I guess so with Bluetooth Classic, you mentioned there's the Bluetooth adapter, then you sort of have like you search for these Bluetooth devices, then you have the Bluetooth socket opening up, and then there's like the Bluetooth server socket. That makes sense. How does it work in the land of LE? Do we have like a similar mechanism with when we work with Bluetooth low energy?
Sure. I mean, some of the steps are the same because there's still the process of accessing the system service, discovering the devices around you, and retrieving instances of those devices. So you'll see a lot of the classes in the framework acting the same in terms of those lower layers. Where things do get a little bit different is that I mentioned before that device discovery is a little bit different between LE and Classic. So when you're scanning for devices, there are different APIs if you're doing LE scans versus just scanning for Classic. So there are separate APIs for Bluetooth LE scanner and things like that allow you to scan for devices around you that specifically implement Bluetooth LE or Bluetooth Smart as opposed to scanning for other devices that are Bluetooth Classic. Because again, it's a totally different paradigm in terms of doing that. Some of the other things that are a little bit different between LE and Classic, I didn't really mention this before, but there's a required step as part of connecting to a Classic device known as pairing. Which is a security step. It's basically, it's a portion of the process where the user is supposed to intervene. And you've probably seen this if you have Bluetooth devices where you connect to your car or something and you have to enter in the 4-digit code before you can actually connect to it. That's a security step known as pairing. The idea behind that is it allows the connection that happens subsequent to that to be secured or encrypted. The pairing process is really just involved in deriving an encryption key that is going to be used to encrypt all the traffic that goes beyond that. That's essentially a required step in Bluetooth Classic. With Bluetooth LE, it's not. You can still pair devices if you need that communication to be encrypted and secured. But by default, Bluetooth LE communication, if two devices just connect to each other to send LE data, those devices don't have to pair with each other. This also helps make things faster and lower power just because it's fewer steps, in the overall process. So there are some additional pieces in there that might be a little bit different. From a functional perspective, the biggest difference between LE and Classic is that Bluetooth LE uses a primary profile called the generic attribute profile, or GAT. And really, that's just a way of organizing data in a glorified key value store, where instead of streaming data over a socket, you're basically reading and writing key value information in a table. This, again, goes along with the idea that LE transfers are typically small individual packets as opposed to streams, which, again, helps them be lower power. But so the APIs that you'll see associated with the Bluetooth GAT functionality when you're connected to an LE device is a hierarchy of services, characteristics, and descriptors, which is really just a way of identifying and grouping individual key value elements, like what is the temperature of this thing? How should I configure the reporting interval? Just readable and writable data that you can read and write using individual keys, which are represented as UUIDs.
Makes sense. And one quick follow-up question from what you mentioned before. You said the APIs around the two are different. You meant specifically the Android APIs, right? So you're talking in the land of Android that the way those APIs work is a little different.
Yeah, that's correct. The idea that at the very lowest level, you still access the same system service, and that system service is responsible for starting a scan, and then from there you can access a device. Those two things are common, but from that point, the Android APIs diverge whether you're dealing with Bluetooth Classic and sockets or Bluetooth LE and GAT.
That makes sense. All right. So for folks who are really interested about going into the specifics of how the GAT profile works and some of the other specifics, I know Dave has a fantastic talk, and we'll add a link to this in the show notes. And that's basically the talk that I watched to sort of get an understanding of how each of these things work. And this is a talk that he gave on low energy, and you've dove into some of these details in a very interesting way. So we'll definitely add a link to that in the show notes. A quick question about the GAT profile. So this GAT profile, you mentioned it's like this glorified key value data store, right? So each time the communication that happens between the device and the server and the device that's listening in, is it the whole GAT profile that's basically just transferred? Is that how it works? Or am I misunderstanding something there?
Yeah, so the idea there is that there's two roles primarily associated with this. So you have a device that we call a peripheral, which is also oftentimes referred to as a server, a GAT server. This is the device that actually houses and implements that key value store or that table of data. And so oftentimes if you're looking at this, you've got the device that has the data and the device that wants to interact with that information. And so the peripheral device is the one that owns that GAT table of all those individual attributes that probably represent things like the temperature value or the heart rate value. So the peripheral device is the device that has the sensors and owns all the data. The devices that connect to that are often referred to as a central device or a GAT client. And so that is more often than not, that's your phone. That's the device that is scanning for these, making a connection, and then reading the information off of that in individual requests. So, the idea is that from your application, you make a request of a specific characteristic that lives on a specific service. And that characteristic is one of those pieces of data, like the heart rate value. And some of those characteristics could be readable only, or they could be writable. So you could have configuration values where maybe your phone tells that heart rate monitor that it should be taking samples every 5 seconds or 5 times a second. And making those configuration changes from the device as well. So all that data lives on the peripheral, and then it's transferred back and forth individually based on requests from one of those central devices.
Oh, okay. That makes a lot more sense, I guess. So there's also this concept of like the broadcaster and the observer in terms of these roles, right? Like, so in your talk, you mentioned, like, I think I have a decent understanding of how like the central and the peripheral works. How does the broadcaster and observer sort of like fit into this equation?
Sure. So one of the really neat things about Bluetooth LE that we didn't really have with Bluetooth Classic is there's this fundamental concept that inside of the what we call the advertisements, which are the packets that are sent out by devices so that they can be discovered by others. So this is during the process when devices aren't yet connected to each other. Inside of Bluetooth LE, there is actually a portion of that advertisement that applications can fill with data. Which wasn't necessarily true inside of Bluetooth Classic, or at least it wasn't used in the same capacity. What this allows us to do is create devices that are actually broadcasting the information they have to provide without requiring that someone connect to them to get that information. So, under the same idea, let's go with the temperature sensor, right? The Bluetooth temperature sensor could house that information in a GATT profile and could respond to requests for it after a connection. Or it could simply advertise that data inside of that payload every time it's telling the world that it exists. And then the client device, which we refer to as an observer because it doesn't have to actually make a connection, which is what a central would do. This device could just be listening and scanning for those advertisements like it would be doing if it were going to make the connection, and simply read the data out of each of those advertisements without having to make a connection to get it. So this enables what we've effectively started referring to as beacon applications, right? A beacon application is an idea of a device where I'm transmitting data out into the world and I'm giving you everything I have. You don't have to connect to get anything more. And then the devices can simply walk by and observe that information and get everything that they need to know about that device. And then obviously the applications for that have been moved on into things like indoor location, physical web, and all these other beacon applications that you've probably seen in the news for one reason or another. That centers around the idea of broadcasters and observers where no connection actually takes place.
Okay.
That makes a lot of sense. And just, I guess, like a word to the listeners, this sounds so cool. And I'm like, oh my God, I should be adding this to everything that I have. There are certain API changes though, right? Like I think the whole broadcaster mechanism was brought in Android 5. So that's like Lollipop, I imagine.
Yeah. So, Bluetooth LE functionality was originally added to Android in Jelly Bean 4.3. So that's API 18. And that was, as you mentioned, that was just the basic functionality of scanning for and connecting to other devices. So it was essentially implementing the central role and the observer role. Which in a lot of cases is all we need because that's primarily what the devices are doing in those types of applications. Inside of API 21, which is Android 5, that's when they added the ability for the device in your pocket to become an advertising to device, or to act as a peripheral where it could receive connections and serve data up to other requesting clients. So they added the other half of that functionality in API 21. Now, just kind of a side note there, there were some underlying changes in Android over time that really in the early days of the LE APIs made the Bluetooth stack fairly unstable. And this is a well-known problem where, if you're doing Bluetooth development on the Android 4X system, there were a lot of instability issues there and incompatibility issues with other platforms and other devices because of some changes they made under the hood in the architecture of the system. So in addition to all these brand new shiny APIs that were added in Lollipop, I also like to recommend to folks that if at all possible, doing Bluetooth LE at all with a min SDK of API 21 is often a good thing to save your sanity, just because it's also a heck of a lot more stable in API 21 than it was in the earlier version.
Yeah, I remember really early on, I worked with a guy who was doing stuff making Bluetooth-enabled garage door openers for people who rode motorcycles. And he ran into so many issues with just Bluetooth randomly disconnecting, randomly not, losing pairing, just all different types of crazy things. And this is back when, right after the API level like 14 was just starting to come out. So he ran into all of them, and I witnessed it, and it was not a fun time for him at all.
Yeah. And I would say even today, things are not awesome. Right? I mentioned before that
disclaimer.
Both mobile platform vendors have made their own decisions about how this stuff should work to simplify it for developers like us. And unfortunately, those opinions tend to conflict sometimes. So you may still run into cases where if you're trying to have an Android and an iOS device talk to the same peripheral, one might work and one might not. It's just that things are 1,000 times better now than they used to be.
And what was the root cause for all of this instability and these problems? Is it basically the architecture? Why is this problem there?
Yeah, so basically I mentioned that Bluetooth LE APIs were introduced in Android 4.3. In the prior version to that, Android 4.2, Google went through and completely redid the entire Bluetooth stack in the platform. Up through really the very beginning of Android all the way until Android 4.2, there was a well-known, very mature Bluetooth stack called BlueZ that has been used in Linux forever, that was part of the Android platform, and that's really what they were using for all their Bluetooth communication. In 4.2, primarily for licensing reasons, they moved away from that and started with a clean room from scratch implementation written by Broadcom called BlueDroid. And because it's brand new from scratch, it basically hasn't had a lot of time to mature like BlueZ has. And so when they started to make those changes, which was literally one API level before Bluetooth LE came in, they were still working out all the kinks in the actual stack itself. And I would say they're even still continuing to make those improvements just to get it on par with the level of maturity that something like BlueZ had. So unfortunately, Bluetooth LE sort of suffered from that calamity and the collateral damage associated with that happening just before those APIs came out. And so sometimes I think the LE APIs get blamed for what the Bluetooth stack just isn't quite yet capable of doing.
Oh, so it's not even the maturity of Bluetooth technology in general. It's the maturity of the implementation on Android for that Bluetooth technology.
Correct. Yeah, because we've only had that for a few API levels now, 5 or 6.
Dave, let's assume that there's some folks listening that we've piqued their interest a little bit and they want to start working with BLE and Android. What would you recommend they go pick up so they can actually start building something? What would be something they could tinker with? Maybe do they buy a beacon? Do they buy a different device? What would you recommend for someone who wants to get started and just start playing with BLE?
Sure. I would say it depends on your means, because to some degree, the easiest thing to do is have 2 devices. But not everybody necessarily has that accessible to them, but it's the most flexible approach. So if I have a phone and a tablet, for example, or maybe I have an Android device and my wife has an iOS device or something like that, right? Just the ability to have 2 devices that are programmable is probably the easiest way to get started, because you can tweak different things, you can tinker with it, you can see how both sides of the equation actually work using a fairly high level programming environment, right? You're not having to write embedded code to get one of those things to work. But not everybody has a bunch of devices laying around like those of us who are, developers, Android developers maybe do. So the next level from there, I would say, is probably to play around with beacon stuff. I think it's the lowest barrier to entry in getting into Bluetooth, because you don't have to deal with all the connection stuff. You can start playing around with just scanning for devices, reading the data off of it, and making some sense of it. So there are a lot of beacon manufacturers that produce devices that are primarily just location-based, but you can find other manufacturers that are actually producing beacon-type devices that broadcast sensor information, so that you can maybe do something interesting with that without having to deal with connections. So beacons, I absolutely agree with you, are a good sort of initial step into it. And then once you get comfortable with that, go buy a heart rate monitor like a Polaris or something like that, where you can actually connect to a device, try and read real data, and see what happens.
Okay, so this could be something useful for those folks out there that maybe are suffering from even like different diseases, such as like diabetes. They could possibly find a Bluetooth enabled device if they felt that inclined to do so, and communicate with that if they wanted to as well, right?
Yeah, absolutely. I mean, those things exist. My nephew's a diabetic, and so I'm always out looking for things like that, as interesting ways to kind of solve that particular problem, because it's a big one.
Yeah. And I think the important first step, going back to your point, is like if your wife has an iPhone device, you should probably move her to Android. That's
step number one.
Let's just say those conversations are still ongoing.
Yeah, my wife's on iPhone too. It's an evergreen debate.
Slowly they shall see the light.
That's right.
They do. They are slowly.
All right. So like a couple of other important things that I feel is worth mentioning is, Dave, you've given a couple of talks, and I think we'll add links to those, there are YouTube links to talks that you've given. One is obviously on Bluetooth LE matures. That's, I guess, the title of the talk. And I think that's the one where you really dive into the nuts and bolts of Bluetooth LE. So we'll add a link definitely there in the show notes. Another decent place to start is also just like the developer documentations, right? I think the Android developer docs do like a half decent job, I guess, of explaining Bluetooth Classic and LE at a high level. Are there any other places that you think is worth exploring?
This is probably one of the few times that you'll actually hear me recommend such a thing. But I would say that in addition to the developer documentation that's on the Android site, I would actually recommend people go look at the core Bluetooth documentation that's on Apple's website for iOS as well. Just because if you see the two of them side by side, you get a really good idea of what Bluetooth can do, as opposed to necessarily what each individual platform chose to implement. So it sort of gives you a good idea of, okay, so these things called services and characteristics, like that's a Bluetooth thing. Both of them do it the same way. And you get a really good idea of where Bluetooth lies and what is Bluetooth LE, as opposed to the individual interpretations of that. Another rather unpopular opinion amongst most is I often tell people to just go read the spec. Go to bluetooth.org, download the 1,000-page document. The reason it's huge is because it covers all of Bluetooth, but the Bluetooth LE portions that are in there are relatively narrow. And so you can get a really good idea of what is a service, what is a characteristic, what do all those little flags in the advertisement mean that my Android device is sending, but I can't actually control. Understanding those things helps understand when you run into an incompatibility issue between, say, iOS and Android. You can start to understand why that's happening and see if you can work around it, or if it's something you need to change on the device. Those things happen. And unfortunately, the best way to understand what those interpretations came from is to read the LE portions of the spec.
That makes sense. I guess, we'll add a link to those in the show notes. But to be honest, I'm going to leave that as like a last. For the Bluetooth spec, thousands of pages written by some corporation does not seem extremely enticing, but I get where you're coming from. It is probably like one of the most comprehensive like data points, right?
Yeah.
Perfect. This was fantastic. Thank you so much, Dave. I've learned so much just speaking.
Thank you.
Yeah, like I don't think I've ever had this much knowledge about Bluetooth ever. Just like talking with you has given a lot of information.
Oh, well, thanks, guys.
Yeah, I opened my eyes to a lot of things that I had no idea about and how Bluetooth works. So thank you for this deep dive. I can't say thanks enough, and hopefully the listeners feel the same way.
Absolutely.
Yeah. So I'm super stoked now. I'm going to try to dust off all those like beacons I have lying around or that have been given for free at hackathons, and I'm going to try and get something working. Dave, this has been amazing. Thank you so much. But we also feel we should point out that there's a really interesting conference coming up. And this is one that I know both Don and I and like a couple of the others in the Android developer community are super stoked about. So before we let you go, I really feel it's important that we let you talk a little about it. Can you tell us a little more about 360 AndDev?
Yeah, absolutely. So we're running an Android conference here in Denver, which is where I'm based, called 360 AndDev. It's organized by myself, Chuki Chan, and John Wilker, who's the amazing guy who also does 360 iDev, 360 Flex, and other 360 conferences that you may have attended or are aware of. So we're running it in Denver. It's in July, the 28th and 29th. July is an amazing time to come visit Denver. We've got mountains and hiking and all kinds of good stuff going going on. We've got microbreweries all over the place. So it's a really fun place to hang out in the summer. And I think we've done a really great job of accumulating a great lineup of really good speakers from the Android community to bring to the Rocky Mountain region. So if you live in that area, you have no excuse. And if you don't, I still think you should come visit Denver in the summer. For the listeners here, we've created a discount code. Just use Fragmented, and that'll give you 10% off registration. And I'm sure you'll put that in the notes as well. But, it's going to be a great time. It's community led, and we're going to have a lot of fun. So we want you to come have it with us.
That is fantastic. And I know, like, just seeing the lineup of the talks, like you said, like, we're super stoked about some of the folks who are going to be speaking. So absolutely. And now with the coupon code Fragmented, like, there's absolutely no reason for our listeners not to attend. So definitely. Thank you so much.
Thank you.
We're super stoked about that. If people want to reach out to you otherwise, what are some nice places they can do that?
Sure. So I'm devunwired on Twitter, Dave Smith Dev on Google+, because for some reason I thought I could actually get Dave Smith, but that was already taken. Or my blog where I write a lot of this content, or there'll be links to all the videos you mentioned there as well, which is wiresareobsolete.com.
Fantastic. And for the longest time, I didn't know you were the person devunwired. Like, I think I have met you at conferences knowing that you're Dave Smith, but I think it was like the second conference where it really hit me when I was looking at it and I was like, oh my God, that is devunwired.
It's kind of weird to be known by a pseudonym, but
yeah, well, your blog is super famous, and I would suggest listeners also having a look at your blog and some of the interesting content that you have there. The show notes for this episode would be fragmentedpodcast.com/episodes. So all the interesting links we'll add in that place. If you have feedback or suggestions for us, as always, you can reach Don and me on our Twitter handles. What would that be for you, Don?
Twitter handle would be Don Felker with 2 N's.
Perfect. And I'm Kaushik Gopal. No N's in my Twitter handle, so you can reach me there. Fragmented Cast is our Twitter handle.
Before we get going, I want to thank our sponsor for this episode one more time, and that's Rollbar. With Rollbar, you get the context, insights, and control you need to find and fix bugs faster. Because let's face it, relying on your users for error reports isn't really a best case scenario. And digging through those logs, well, that's not exactly my definition of a good Friday afternoon. So if you're interested in Rollbar, go to rollbar.com/fragmented and you'll get the Bootstrap plan for free for 90 days. That includes 300,000 errors tracked for free. Thanks again, Rollbar. We appreciate it.
Thank you, folks, for listening. We will catch you next week.
Bye-bye.
I also realized this very important piece of information. Bluetooth LE, BLE is bleh.